Welcome to this explainer. Today, we're going to explore the hidden architecture of the Internet's front door. You see, the evolution of cybersecurity isn't just some boring timeline of technology. It is an intense, ongoing arms race between defenders and adversaries. Every single time we build a taller wall, the attackers just go and build a taller ladder. And the most fiercely contested battleground in this entire war? It's exactly how you log in.
Here is our roadmap for today. We'll start by looking at the fundamental problem with passwords, move through the password manager upgrade and the two-factor evolution, expose a pretty massive phishing loophole, and finally, look at defeating phishing entirely. Let's get right into it.
Okay, let's dive into this. Section 1. The problem with passwords. Every single day, you type a password into a little box, probably thinking it's a perfectly safe secret locked right in your head. Well, let's shatter that illusion right now. The first massive flaw we have to talk about is entropy. Typical human-made passwords, even the ones where you carefully swap an E for a 3 or throw an exclamation point at the end, only contain about 10 to 20 bits of entropy. In the realm of cryptography, that is alarmingly low. It literally means an adversary only needs a few thousand guesses to break in. Now, you might be wondering, but wait, websites lock you out after 10 failed attempts, right? True, but an attacker on the internet doesn't just guess your password 10 times on one account. They take one super common password and guess it across a million different accounts. Because the entropy is so low, chances are that password belongs to somebody.
The second, and honestly perhaps more fatal flaw, is this concept of a bearer token. Think of it like walking up to a club and handing the bouncer your physical ID card to just keep. Whoever holds the token is automatically assumed to be the owner. So if you accidentally give your password to someone else or a database leaks, they don't just have your secret, they literally are you to the computer. They can perfectly impersonate you across the entire internet. Combine this with the fact that humans notoriously reuse passwords across multiple sites, and you've got a recipe for absolute disaster.
Which brings us to Section 2, the password manager upgrade, taking human memory completely out of the equation.
This brilliantly illustrates the solution. Password managers step in and generate separate, incredibly long, cryptographically secure strings for every single website you visit. As you can see, the secret for Facebook looks absolutely nothing like the secret for Amazon. So you no longer have low entropy, and you literally never reuse a secret. A breach on one website doesn't compromise a single one of your other accounts. It's a massive, massive upgrade.
Yes, password managers are a fantastic upgrade. But, and this is a massive but, they still fundamentally rely on bearer tokens. Sure, the strings are much stronger, but they are still just strings being sent over the network. If a hacker manages to slip malware onto your laptop, that malware doesn't need to guess a single thing. It simply grabs your keys right out of the password manager and authenticates on your behalf. A compromised laptop basically gives the adversary the keys to your entire digital life.
So we had to evolve again. Section 3, the two-factor evolution.
To truly fix this whole bearer token vulnerability, we had to shift the battlefield entirely. We needed to require something you have, in addition to something you know. Enter the challenge response protocol. Let's go back to our club bouncer analogy. Instead of you handing the bouncer your ID card, which, remember, someone else could easily steal, the bouncer shouts out a random complex math problem. Your device takes a secret key it shares with the bouncer, mixes it with that math problem to create a message authentication code, or MAC, and shouts the answer back. The bouncer just verifies the math. If an attacker intercepts your answer, it's totally useless, because the next time you log in, the bouncer is going to ask a completely different math question.
So how do we get this second factor physically away from your potentially compromised laptop? Well, initially, we used SMS text codes, but while SMS does get the secret off the laptop, it introduces a massive new flaw. It relies entirely on telecom networks. If an attacker walks into a mobile carrier store and ports your phone number to their own SIM card, a classic SIM swap attack, they get all your codes. That's exactly why authenticator apps are absolutely crucial. They cut the vulnerable phone network out of the loop entirely.
Let's look at how this builds into an incredibly elegant system called Time-Based One-Time Passwords, or TOTP. Your phone and the server share a secret key, which is usually established when you scan that little QR code. Instead of the server texting you a random challenge, both your phone and the server use the current time, specifically the time divided up into 30-second windows, as the challenge itself. Your phone combines the current time and the secret key to generate that familiar 6-digit MAC code. The best part, it requires absolutely zero network connection, completely locking out attackers who try to hijack your phone lines.
Now, what's really interesting here is Section 4, the phishing loophole.
It feels like we solved it all, right? We have unique keys, we have time-based math happening locally, no phone networks. But we are about to pull the rug out once again. The fatal loophole in all of this is us. What happens if a user is tricked into navigating to a fake website that looks exactly like Amazon? The human dutifully opens their Authenticator app, finds that mathematically perfect, totally secure 6-digit code, and just hands it right over to the hacker. The hacker instantly turns around, feeds that exact code into the real Amazon website, and boom, they are in. The human has just done the hacker's job for them. This is phishing, and honestly, as long as humans are the ones copying codes from one place to another, the entire system is vulnerable.
So how do we fix that? Section 5, Defeating Phishing with U2F.
To take human error out of the loop completely, we rely on hardware keys. These little physical USB keys represent the absolute peak of the current authentication food chain. And this concept right here, this is the major aha moment. A human might easily be fooled by a fake website using a 0 instead of an O in the URL. But your web browser, it is literally never confused. It strictly parses the exact TLS certificate and the exact URL origin you are visiting. By letting the browser talk directly to the physical security key plugged into your USB port, we bypass human eyeballs entirely.
Here are the brilliant mechanics of Universal Second Factor, or U2F. You plug the key in, the server sends a challenge, but here is where the magic happens. Your browser takes that challenge, adds the exact URL origin you are currently looking at, and sends both directly to the security key. The hardware key then uses public key cryptography to digitally sign that combination with a private key locked securely inside the physical device. If you happen to be on a phishing site, the key signs the fake site's URL. When the hacker sends that signature to the real server looks at it, sees the fake URL locked inside the signature, and instantly rejects it. Just like that, phishing is mathematically defeated.
And we need to highlight how this changes the stakes entirely for the server storing all this data. If a server's database of passwords or bearer tokens is breached, it is downright catastrophic. Hackers can instantly log in as absolutely anyone. But with U2F, the server only stores your public key. If a hacker breaches the server and steals the entire database of public keys, it's completely harmless. They can't forge the necessary signatures without physically holding your specific USB key in their hands.
The system even goes one step further to ensure trust. I mean, how do you know the USB key you just bought on the internet wasn't tampered with? It's a concept called device attestation. Baked right into the hardware at the factory is a digital certificate from the manufacturer. So when you register the key, the server actually checks the certificate to mathematically prove you are using legitimate hardware, effectively stopping hackers from handing you a backdoored device.
But, the arms race never truly ends. Today, U2F is evolving into passkeys. This is where the private keys don't just live on a physical USB stick anymore, but are stored right in your device's secure enclave and synced across your phones and laptops via the cloud. It's incredibly convenient, and yes, it's highly secure against phishing. But as we start synchronizing our most closely guarded secrets up to the cloud, it leaves us with a pretty provocative final thought. Have we finally won the cat-and-mouse game of user authentication? Or have we just given the mouse a brand new path to explore? Thank you so much for joining me for this explainer, and stay safe out there.